Okay, so this is the Chapter 4 test review. Okay, we're going to go through and look at the questions on the Moodle version. We've got a few different versions out there, but the one we're going to be looking at starts with x squared minus 49, and you're being asked to factor it. Hopefully you recognize this as a difference of squares, which means you're going to use the square roots for factorization. So 7 and 7. And because 49 is negative, you're going to have a positive 7 and negative 7. And that's all I'm asking you to do. Later on, that pattern is going to become really important, this pattern right here. When we use it down in questions 7 and 8, it's going to become important. So the reason it's there as a question at all is to remind you to look for that pattern or to build that pattern later. Another problem, number 2, that's kind of preemptive, it's there to help get you started, 72x plus 81. It's one that, if you look at the 16 and the 81, they have square roots, and when that happens, a lot of the time we're going to be looking for the same thing in both parentheses. So I'm going to go 4x and 4x, factors of 81. If you get a square root, which is 9 and 9, because the 81 is positive, the signs have to match. And in order to get that negative, I'd have to use negatives. Now, this is one of those places where you might want to do a quick check. This is negative 36x, and this would be another negative 36x. If I combine those, sure enough, it's going to give me the negative 72x. So this is an acceptable answer, but the reason this question is here is because when you do complete the square, you're going to need that type of factorization to give you 4x minus 9 parentheses squared. So understanding that you can write it as a squared parentheses is really a big, important part of why we're doing question 2 there. So 1 and 2, they're factor problems, which is great, but their real purpose is to remind you about things that are going to happen later in the test. Now question number 3 specifically says you need to use completing the square to solve this. It is solvable by the quadratic formula, but I'm asking you to complete the square at least once on the test, and this would be the place where I'm going to ask you to do it. The first step is to make sure you have a single x squared, which that's a 1x squared, so it's good. The next would be to move the 25, the constant, to the other side. So I'm going to have x squared minus 2x equals negative 25. Now I need to add the perfect number to both sides. We call it completing the square. So I'm going to take half of this. Half of the negative 2 is negative 1. But then I'm going to square that number. A negative 1 squared, a negative 1 times a negative 1, is a positive 1. So I'm going to add 1 to both sides of the equal sign. That'll produce x squared minus 2x plus 1 equals negative 24. Now here, when I factor this, left side, I should get x and x. The factors of the 1 are going to be 1 and 1. Got to match signs to get a negative 2 minus minus. The reason that matters is I need it to be parentheses squared in order to move forward. So you can see how question number 2, at least the factoring piece of it, is connected to this problem. Now I need to get x alone. It's just sitting right here, so I'm going to square root. When we put a root in, we always put a plus or minus with it. So x minus 1 will equal plus or minus. Now when we look at the 24, first we notice it's negative. The fact that it's negative means there has to be an I in the problem. Square root of any negative is going to be imaginary. So we've got our I there. And then not every one of these factors, if this had been 21, 7 and 3 don't have square roots. But 24 can be written as root 4 and root 6. The reason that matters is the square root of 4 is 2. So this is really going to be 2i. Those things came out. And there's the leftover root 6 that I couldn't do anything with. And the last step is to add 1. So x will equal 1 plus or minus 2i root 6. And there's our final answer for question number 3. All right, number 4, I ask you, instead of completing the square, I'm going to ask you to do the quadratic formula. And I've got x squared minus 6x minus 6 equals 0. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I do ask that you memorize it, but just remember the song, and you'll be fine. Pop goes the weasel. All right, so I need to start by identifying what a, b, and c are. A in this case is 1, because it's 1x squared. B is negative 6. And c is also negative 6, based on the order of the numbers you're in. So when I say negative b, I'm looking at a positive 6 plus or minus the square root of. Now this is really important. If you write negative 6 squared in your calculator, it will be wrong. You would either have to use parentheses around the negative 6, or just ask yourself the question, what is 6 squared? It should be a positive 36 minus 4 times a, which is 1, times c, which is negative 6, all divided by 2 times a, which is 1. This is the place where I'm going to grab my calculator. I want to calculate the inside of the square root without the square root, just the inside. So 36 minus 4 times 1 times negative 6. If I just put that all in, I get the number 60. So I now have 6 plus or minus square root of 60 all over 2. Now sometimes the problem stops right here. It just depends on this square root. If we look at the root of 60 and we're looking for those perfect squares, I know that 4 goes into 60 15 times. And because 4 has a square root of 2, this problem can be written as 6 plus or minus 2 root 15 all over 2. Again, this might be a place where the problem stops. It really just depends on these three numbers. Do those divide by the same thing? Can we reduce that? In this case, the answer is yes. We can reduce all of those by 2, making my final answer be 3 plus or minus 1 root 15, or just root 15, all divided by 1. So I divided all that stuff by 2. And there's my final answer. That should be an x equals 3 plus or minus root 15. Now, on the test, maybe it stops here. It just depends on what that number is. If that number is a 39, it stops. If it's a 27, we can go because there's a 9 in it. So it just depends on the problem. Right? Then questions 5 and 6 tell you you're allowed to use any method you want. Now, I'm going to choose to do factoring because I know that they factor. But quadratic formula, it works. Completing the square, it works. Completing the square on number 6 is a little bit harder because of the 3 in front of the x squared. You'll remember that you have to make it a 1x squared, so you'd have to divide by 3, and then you get a bunch of fractions. So typically what we're going to do is, if the x squared is a single, maybe do quadratic, or maybe do complete the square, but quadratic formula works all the time. All right, anyway, so we're going to go ahead and just factor. And so we set up 2 sets of parentheses. This one's pretty easy. It'll be x and x. Factors of 80 that subtract to make 2. I'm thinking of 8 and 10. So 10 and 8. Now, the negative 80 means the signs are not the same. We're going to have a positive and a negative. In order to get a positive 2, I'm going to need a positive 10 and a negative 8. Now, I am not done yet because I was supposed to say what x equals. Well, if the whole thing equals 0, then a negative 10 plus 10 would be 0, and if the first parenthesis is 0, the whole thing gets wiped out. And then here, it would be a positive 8. Really, I'm just switching the sign of the number that's grouped with the variable. Over here on 6, I'm going to go ahead and set up the factoring again. Have 3x and x. Those are the only ways to split the 3. Now, the 8 could be 2 and 4, or it could be 1 and 8. There's not a surefire way to just know for sure, but I mean, I'm a kind of a guess and check type of person. If I put the 2 here and the 4 here, this is how I'm going to check. This makes 2x. This makes 12x. Now, this is important. I look to see if it's addition or subtraction. That tells me to subtract. If I subtract these, the difference between 2 and 12 is 10x. Now, I want the 10x to be positive, so I have to have a positive 12 and a negative 2. To get the negative 2, the negative would have to go there and the positive there. Now, if you need to pause the video right now, you can pause it. I'm going to erase real quick. So pause it if you need to, but otherwise, I'm going to go ahead and erase this stuff because I still have to answer the question. Well, what makes these things 0? We know this one over here will be -4. That one's really simple. If the 3 wasn't here, I would just say the answer was 2. But if you think about the equation 3x minus 2 equals 0, you'd add 2, hence why the 2 is positive. And you'd have 3x equals 2. Well, to finish it, you'd have to divide by 3. So you get x equals 2/3. So it is 2/3. And you can just think about switching the sign and then dividing by that leading coefficient. Okay? So that should get us through the first 6. And good news is we're almost halfway. Question number 7 and 8 are very closely linked. So I'm actually going to do them together, or at least on the same page. You can look at them together. We have 4 over 5 plus root 2. And over here we've got 5i over 1 minus 6i. In the instructions for the section, it says simplify completely, and then in parentheses it talks about rationalizing the denominator. That means no roots, no i's in the denominator. And so we have to multiply by something. Now this goes back to question number 1. Question number 1, I said you need to have that special pattern pop up later. And this is where we're going to see it. If we have 5 plus root 2, we need 5 minus root 2. That is going to fix the denominator. What we do to the bottom, we have to do to the top. Over here, same pattern. I have 1 minus 6i, so I need 1 plus 6i. Now, the actual multiplication we'll do in a second, but that's the setup. That is how to do the problem. Once it's here, now it's just a matter of can you multiply and distribute and FOIL. On top, I'm going to get 20 minus 4 root 2 over. On the bottom, I get 25. That's going to be a negative, because a positive times a negative is negative 5 root 2. Here I get a positive 5 root 2. You should always get those opposites there. And then this one, a positive root 2 times a negative root 2 is negative root 4. All right, I'm going to go back and do some cleanup here real quick. These two guys should always cancel. And what's the square root of 4? That would be a 2. So I now have 20 minus 4 root 2 all over 25 minus 2. That would be 23. And I'm done. Okay, come over to question number 8. It's the same thing. I'm just going to have to deal with the I at the end. I get 5i plus 30i squared over 1 plus 6i minus 6i, we're seeing that happen again, minus 36i squared. All right, and we see those 6i's cancel. That's great. One of the things we have to remember is that while I is the square root of -1, and it comes out when we have a negative and a square root, I squared is actually equal to a -1. So I'm going to cancel these I squareds and put -1s in their places. So now I have 5i. Now this is important. I have 30 times -1. That's -30 over 1. And then I have -36 times -1. That's positive 36. So as I'm going to clean this up the last little bit, keep in mind we like to put the real numbers first, and the imaginary numbers we like to keep them separate. So I'm going to do -30 over 37, because 1 plus 36 is 37, plus 5 over 37, and I stick the I out to the side. That's the preferred, best way to write it. If you write -30 plus 5i over 37, it's okay. I'm not going to mark it wrong, but it is avoiding the better version. I'd rather you have it correct than perfect. Correct and good enough versus trying to be perfect and messing something up along the way. So if you understand how to rewrite it, please do that. But if not, don't stress yourself out about it. Number 9 is the square root of -84. So a couple things. We're trying to reduce this root as much as we can. But we also notice that there's that I. That's negative. It's going to make it an I. So I know there's an I in my answer. The next piece is 84 doesn't have its own square root. So I know there's going to be a square root in my answer because 84 doesn't break down completely. But I need to do some searching to see if 84 divides by a number like 9 or 16 or 25. Or in this case, because it's just pretty straightforward and simple, it's going to be 4 and 21. Well, the square root of 4 is 2, hence the 2 that comes out, and I'm left with a 21. Now, I've seen a lot of people in the past write plus or minus in front of this because they see the square root. But if we don't put the square root in the problem, then it doesn't need a plus or minus. This square root was already there. You're not the author of it, so you don't need to put the plus or minus there. And same thing with number 10. We have the square root of 15 over 7, which we know we can split as root 15 over root 7. But we're not allowed to leave a square root in the denominator, so I've got to turn that 7 into something that has a square root. Well, if I times it by the square root of 7, top and bottom, the bottom becomes the square root of 49, which I know is really just a 7. That's the goal. On top, whatever happens, happens. It turns out this is root 105. So my final answer would be the square root of 105. I couldn't fix that on top, over just a plain 7. It was all about trying to get the 7 not to be in the square root anymore. All right, we turn the page. Now we're going to look at 3 different graphs, okay, and some approaches for graphing them. It's really important that when we graph a parabola, we always state its vertex. It's just part of the way we do it. But we are able to use our calculator an awful lot. Feel free to use it as much as you want to. There are ways to graph these without using the calculator, but I'm going to just assume that we're all going to go down the road of using our calculator. So the first one is x squared plus 2x, and then it's plus 1. All right, when I graph this, I get a parabola like that. I need to know its vertex. There's a couple of ways. If I go to the table and I scroll around, you can see over here all the pattern right here. 9, 4, 1, 0, 1, 4, 9. You see the symmetry? That tells me the vertex is right in the middle of the problem. Now I'll show you on the next 2 how to find the vertex maybe a different way. But one way is to find it on the table. This only works if the x value is a whole number. So it is possible that it might not be that easy to find. But on this problem, it sure is. So right here, what we're going to do is we're going to transfer these points. We need at least the vertex and a point on both sides. The vertex was at negative 1, 0. Negative 1, 0. I'm going to label the vertex at negative 1, 0. And then I need to plot at some of those other points. If I remember right from that calculator, there was 0, 1 and negative 2, 1. Technically that's enough, but I like to go a little bit further. There was 1, 4 and negative 3, 4. And that should be enough to produce the graph of our parabola. And that's all I want. A couple of points on each side, the vertex in the middle with a label, and you're golden. Okay, number 12, it might look different, but it's not. G of x equals negative 1/2 x minus 2 x plus 4. Now there is one benefit to this version that we like, and that is that if we can tell what makes these two things 0, which would be positive 2 and negative 4, we know that the graph has to cross the x-axis at those 2 points. Over here it turned out to only have 1, but on this problem there are 2 of them. And when we graph it in the calculator, we should be able to find those 2 points if we were looking for them. Let's clear that out and do negative 0.5 parentheses x minus 2 parentheses x plus 4. You do need to be comfortable with graphing using the calculator. And sure enough, look at that, negative 4, positive 2. I see it's crossing there. I need the vertex. If I go to the table, I bet I can find it. In fact, it's in the same centered point. It's going to be at negative 1, 4.5. But let's talk about how we would find it another way. Let's go back to the graph. It looks like it's a top of the curve that I'm looking for. So when I go to second, trace, I would be looking for the maximum. I need to be on the left side first, so I'm going to go to the left until I feel I'm on the left side of the bump. Press enter, and then go to the right until I know I'm on the right side of the bump. Press enter and tell it to take its best guess. Sometimes these come out as decimals that we need to round. Other times they come out pretty clean like this. -1, 4.5. So at -1, I'm going to go 1, 2, 3, 4, 5. That's 4.5 would be right in the middle of that. That right there is enough to produce the graph. Now, if I want to, I could plot some more points, but I need at least one point on each side and the vertex being -1, 4.5. All right, we have just two more. Number 13. Okay, number 13 says y equals 2/3 x minus 2 quantity squared minus 5. Now this is the vertex form of the equation, which means I can state the vertex without doing any calculator work. It's always the opposite of what's grouped with x, which would be +2, and then the number at the end of the problem added or subtracted, so it's a -5. So 1, 2, down 1, 2, 3, 4, 5. That is my vertex. I know that much without doing anything else. Now I probably still use my calculator to go through and do it, but if I didn't want to, I don't have to. I have 2/3 parentheses x minus 2 close parentheses squared minus 5. And I'm going to go ahead and graph that. And there it is, that bottom, right where I said it would be, 2, -5, looks about right. But I do need at least one more point on each side, so I'm going to go to the calculator. And I'm just looking for something I can plot. Okay, right there's my 2, -5. So let's put that in the middle of the page. And I see that at 5, 1 and -1, 1, I have a point that's pretty easy to plot. So I'm going to come over here, 3, 4, 5, 1. That would be right there. And it was better make sure. -1, 1. All right, so that would be right there. And there's my graph. Okay, so really I could do all three of them the same way without even thinking about it. Just go to the calculator, ask for the max or min, and move on. But we can also do it based on the way the equation is written as well. Number 14 is going to ask you to find the quadratic function that best satisfies the data given. 2 and -3, -8. So there is a parabola that if I plotted these 3 points, think about it, -3, -8 would be down here, 0, -8 would be like right there, and 2, 2 would be like right there. I could tell there's a parabola that kind of does that. But I want the exact equation. I want to be able to do stuff with it. So I'm going to go to my calculator, turn it on, and I'm going to go to stat. Okay? I'm going to edit the data. Now if there's data in there, I'm going to clear it by clearing the column. I want to put all my x's in the left column and y's in L2. So this would be 0, 2, and I believe it was -3. Over here in L2, it was -8, 2, and -8 again. Now that I have the data in the calculator, I'm going to press stat again. This time I want to slide over to calculate and make a calculation. We're told that we can assume this is a quadratic function that we're looking for. So we're going to run down here to option 5 where it says quadrag, select enter, and we're going to work our way down to calculate and press enter. It's going to give us a 1, a 3, and a -8. Notice it says ax squared plus bx plus c, meaning our answer would be y equals 1x squared, or just x squared, plus 3x minus 8. And if I graphed that, I'm going to just make sure to re-emphasize, this is not important. You've already answered the question. But if I graphed this, x squared plus 3x minus 8, and I'm going to turn on my plot. I'm going to plot those points. Okay, now if I graph it, I should be able to see the dots, and I should see the graph go through the dots. And sure enough, it does, just like we thought it would. It goes right through those dots. So that's validation of what we're doing. Not an important piece to necessarily getting your answer correct, but if you were unsure, that'd be a way to check on yourself. All right. Good luck. I hope that's enough to get you through and help you prep. We'll see you in class.